Okay, we're going to look at the last part of LT3, which is classifying chemical reactions. And we will also look at how to put it all together. How you pull in LT1 and 2 writing formulas for ionic, covalent, and acid compounds. How you write it in equation style. You balance the equation and you classify it. So the first thing you need to do is get out a sheet of paper, or if you've been writing notes on a sheet of paper, that this will need to continue on that paper for LT3 notes. And Ms. Salyer's class, we have a page that talks about balancing equations and the law of conservation of mass. And so this will be the next part. So the first kind of reaction that there is called a direct combination or synthesis. You do need to know both names, but when you identify one, you can use either name. The general picture, you have our little skinny bird and a worm, and then you have the fat bird. So what you have is you're synthesizing, you're pulling everything together into one product. So 2 or more reactants yields one product. An example, just a generic example, would be A plus B yields AB. Chemistry or chemical example would be hydrogen plus oxygen, and those are both in gas form, yield water. One product. So that's your key. 2 or more reactants, one product. Decomposition is the opposite of synthesis. So you're going to have one reactant and multiple products. So one thing is breaking down into 2 or more. Generic example, AB, or you could have ABC, and then you're going to have A plus B, or A plus B plus C. So you have that one reactant forming many products. Or you can take hydrogen peroxide in liquid form, break it down into water and oxygen. That's a decomposition because you have one reactant and many products. Your single replacement reaction is your third type. Your generic example, you have AB plus C. In a single replacement, you always have a single. And then A will get with C and B will be left over. Now, you will always have a metal and a non-metal in this compound. So a positive and a negative. And this C, in this case, is your non-metal. It's taking the place of B. But you have to remember, 2 positives are not going to match up. A cartoon example would be Fred and Wilma plus Betty. Betty's by herself. And then Betty's going to get with Fred, and Wilma's going to get kicked off of the compound. So a single gets into the compound. Here's some chemistry examples where you have A plus BC, and A is taking B's spot. So it's AC plus B. Or Zn plus HCl. Remember, these are both positive ions, so they cannot be together on the product side. Zn takes the place of H, and it gets with Cl. The way you'll know it's a single replacement is if you have a single, and you have a compound, and the single gets in the compound. Metals will always replace metals. They'll never get together in a compound. They replace. Hydrogen acts as a metal. It's an alkali metal, or it's in that group. It's not a metal, but it's a positive 1 ion. So metals replace metals or hydrogen. Non-metals replace non-metals. Double replacement reactions involve 2 compounds that swap partners. So if you look at a generic example, AB plus CD, positive gets with negative, A with D, positive C gets with negative B. Silver is going to get with bromine. Magnesium is going to get with chlorine. So you will have a swapping of partners. AQ in parentheses means aqueous. It means it was a solution. But in a double replacement, it will look really long. You'll have a lot of elements. It looks very complex, and those are typically double replacement. The last one's called combustion. It's your favorite kind. It's when things catch on fire or burn. Typically, it's a reaction where you have a hydrocarbon. CXHY means this number can be any number, and this number can be any number. And here's 2 examples. The main thing is oxygen is always a reactant. Water and CO2 are always products. Now, this doesn't have to just be a hydrocarbon. See this word right here? Hydro means hydrogen, carbon means carbon. So there are other compounds that also burn, as you know. But if anything's burning, typically that is a combustion reaction. So if you're thinking like, well, Germ-X or alcohol burns, that's true. Oxygen has to be there, and water and CO2 are your only products typically. So you have a hydrocarbon plus oxygen yields CO2 and water. So oxygen has to be present, CO2 and water are the only products. There will be no other products. That's the one that everyone always forgets. So please remember, O2 has to be a reactant, CO2 and water are your only products. Okay, the first paper I want you to look at with your notes is this one. It's actually shrunk down on what you have, and it fits on the left half of the page. And I want you to go through and label these, what type of reaction they are. We can do the first two together. If you have 2 reactants and 1 product, look back at your notes. 2 forming 1. I always tell kids, think about it like what you do in English class when you read a whole bunch of different sources and come up with one big idea. It is called a synthesis, and that is what it is in chemistry as well. You're synthesizing, you're pulling it all together. It comes and forms one product, versus you have one reactant that forms many products. Decomposition. Go ahead and write out the full name so you can have practice doing it so you don't forget what these words are. Don't shorten them yet, because as you shorten them, you'll just kind of forget what the words are. When you get to the quiz, you won't know what they are. One more. We have zinc, and then we have a compound, and then zinc gets in the compound. That's a single replacement. Go ahead and finish those out, and we will look at the next thing. All right, now looking on the right side of that same page, let's go through and do a few of these together, and then you can finish those out. Underline the reactants. The reactants are always going to be on the left side of the yield sign. Circle the products. The products are always going to be on the right side of the yield sign. Balance it. If it's already balanced, indicate so. I have 1 Fe. I have 2 Fe's, so I try a 2 here. 2 O's and 3 O's. So I have to think, all right, if I add a 1 here, it doesn't go 1 plus 2 gives me 3. 1's already here. If there's no number there, it's a 1. So I have to think about lowest common multiple. What can I get them both to? If I put a 2 here, it'd make it 4. I can't get this to 4. If I put a 3 here, it gets it to 6. And I can get this one to 6 by putting a 2. So that's my lowest common multiple, is 6. So a 3 goes in front of this one, and 2 in front of this one. Now that 2 also got distributed here, so 2 times 2 is 4. All I need to do is change my first coefficient to a 4. Now, what kind of reaction is this? 2 reactants, 1 product, that's my synthesis. You try the rest. All right, hopefully you paused and worked on those, and now you can check with the key. I have them worked out here. If they need to, I guess I didn't underline all of my reactants and circle all my products, but you can go through and do that. Anything on the left side are reactants. Anything on the right side are products. So go ahead and check your answers. Oh, yep, the last one, number 9. Number 10, you just needed a 2 in front of the HCl, and it was a double replacement. All right, on the same worksheet, flip it over to the back. This is where we put it all together. So I need you all to realize that you're going to have to bring in LT1 and 2 to your bank of knowledge when you complete writing complete chemical equations. So the first thing I'll do is I'll go back over the key with you, how you know if it's ionic, covalent, or an acid. Okay, I would write this down every time I was about to do anything like this. I'd write my key down. Maybe have it somewhere on a note card or something that you can just pull out and look at it. Ionic, you're always looking for that metal. Okay, and your key is cross those charges and reduce. Covalent, you're looking for nonmetals and semimetals, and/or semimetals. Prefixes are your keys. Follow them. Don't cross them. Don't reduce them. Acids. For binary acids, which is all regular chemistry, needs to be prepared to look at. So for binary acids, it starts with H and it has one other element. And it goes hydro, root word, so chlorine, but you change the ending to ic, so hydrochloric acid, hydrobromic acid, and so forth. For pre-AP, We also have ternary acids, so that involves a polyatomic ion, and your rule is 8 turns into ic, there's no hydro, ite turns into us, there's no hydro. So that's your ternary acid rule. So you go up here and you look at your compounds given, and you label those as ionic, covalent, or acid, and you write the formula. Aluminum bromide. Aluminum is a metal, so I have to cross charges. Look at your periodic table and see that the charges are at the top of the group. Cross them. AlBr3. Will react with plus sign. Chlorine. Okay, here's where Hofbrinkel comes back. Told you guys, you've got to remember Hofbrinkel, and that's because all of these alone are unstable. Thus, they form pairs, and they're called diatomic molecules. Cl is part of our diatomic molecule group. To form, yield sign. Bromine, it's part of Hofbrinkel. It needs a 2. It's unstable by itself. And plus sign, aluminum chloride. You will want to pick up this Al, pick up the Cl2, and slap it down over here. You cannot do that. You have to cross the charges. This is a whole other compound that you have to write. So AlCl3, crossing those charges is how I got there. Now, you need to balance the equation. Remember, you can only add coefficients. If it helps you to do little dashes in front, feel free to do so. 3 Brs and 2 Brs. I know that that lowest common denominator is 6, so I'm going to get them both to 6. That gave me 2 Als. I'm going to go ahead and stick my 2 there. And now that gives me 6 Cls. So I'm going to go ahead and stick my 3 there. And now my equation is balanced, and finally you classify. I have a single and I have a compound. My single gets in my compound. So that's called a single replacement. I want you to try the rest. Pause so that you can try them, and then I will show you the key. I will work out one more with you though. All right, so I'm going to do it down here. Magnesium metal, Mg. Okay, is it part of Hofbrinkel? No. It has a positive 2 charge, but that doesn't matter. It's not in a compound, so you're not crossing it. It does not get a 2. Do not write a 2 next to it unless it's in Hofbrinkel. Reacts with plus sign. Aluminum chloride. That's a metal, so I got to cross my charges. So it's AlCl3. And produces magnesium chloride. That's a metal. I got to cross my charges. Mg is a +2, Cl is a -1. So it's MgCl2. And aluminum. Aluminum is a positive free charge, but that only matters if it's in a compound. It's not part of Hofbrinkel. It does not get a 2. You do never bring the charge down and make it a subscript. Let's balance it. 1 Mg, 1 Mg. 1 Al, 1 Al. Our Cl's are wrong. Lowest common denominator is 6. 3 times 2, 2 times 3. That makes us have 2 Als. I'm going to go back through and check. Always go back through and check. 1 Mg, I have 3 Mgs. So I'm going to need a 3 right here. So now it looks like I'm balanced. Single replacement again. I have Mg, my single, with AlCl3, which is my compound, and Mg gets into the compound. So for each of these, you need to follow your rules for writing formulas. And you'll have to write the formulas. Pay close attention to if it says reacts with, plus sign, produces, or forms as a yield sign. And don't forget to balance. You have to balance the equations. I'll put the key up next, so let's pause. Okay, so here's the key for 3 through 7. You will notice I put a parentheses around OH before I cross that charge. Make sure that you do that. Electric current was called a catalyst for this reaction. All catalysts will go over the yield sign. They're not part of the reactants or products, but they make the reaction happen. They start it. So catalysts go over the yield sign, and that's why I put that there. The rest are pretty self-explanatory.